Welcome to qnawire.
So here you have a situation where you have a rod representing this athlete that's jumping over a bar, and you're told that this rod makes some angle here that's equal to 90.08 degrees, and this athlete here is jumping over the bar, and they want you to find how far below the rod the center of mass lies. So essentially, we want to calculate the center of mass with this bent rod system. And we know that, so the position of the center of mass, in this case in the y direction, is just 1 over the total mass. And then we integrate this with some y times the change in mass here, Tm. So this is what will give us the center of mass position. I'll call that y prime. But the center of mass position is going to be calculated from some reference here. So in the end, we're going to want to say that, so the total height here, which is again going to be just the radius of that, so that's the radius minus our y prime, is going to be equal to the center of mass location right below, so the distance from, so this distance here that the center of mass is going to be ycm there. So now we have set up the problem. Now the only thing that's left is to actually calculate it in terms of the values that were given. So first, let's simplify these angles for a minute. So we know that this thing, let's just assume that it's in the middle, and so we know that that's 180 degrees. So if it's 90 degrees in the middle here, then you know that that's 44.96, and this angle here will be 135.04. So now what you want to do is convert these angles to radians, because you want to be able to find the limits here in terms of the angles. But in this case, so let's first now work on our integral definitions here. So we want to find dm. So essentially, we assume that we take a small piece of this rod here and want to calculate its mass. But we know that the total mass of the rod is m, and the rod is of length L. So if we assume that it's a uniform rod, we know that in this little mass here, dm, is actually going to be equal to, so dm is going to be equal to that, the whole, so the mass distribution, so the mass per unit length here is going to be the total mass over the length multiplied by the length of that little piece here. And the length of that little piece is going to be something like, so if you assume that this is our little piece here, it subtends an angle d theta here, and that's r, so the arc length for our little piece is actually just r d theta. So this is going to be times r d theta here in terms of the angle. So now we have a definition for our mass that's going to go in here. So now we have our equation that says y prime is equal to 1 over the total mass integral of y times m over L r d theta here. And now you can go ahead and convert your angles here into radians, because we're always going to be calculating these in radians. So we know that if you convert this 44.96 to radians, that's about 0.0 1.785 here, and this is about 2.357. So these are your limits of the integration, and that's your formula here. So now we notice that we have certain things that we can simplify a little bit further here. So the first thing that you want to, now let's take out the constant. So this is m, that's m. So that's clearly going to cancel over here. So we can just go ahead and notice that y here is the height, or it's the position of this little thing with respect to our reference here. So this would be y. And we know that if we have an angle theta, this y is just our side theta. So now we can also just go ahead. So we now have 1 over L, and the y is just r sine theta. And r in the radius, again, the radius is the same because this is just an arc length here. So this is now going to be r squared because we have 2 radii here. So r squared integral of sine theta d theta here. So now we have simplified, and then you want to put your limits of integration in here. And then the next thing that we want to do is we want to probably simplify this a little further to r in terms of L, because we're not given r. So we know that if we have the total arc length here that we are going to find, the total arc length L is just going to be equal to r theta, the total angle times the total radius. So it means that r is actually just L over theta, where theta is this angle 90.08. So this now also goes into this equation where it's now going to be, so r is now going to be L squared over theta squared, but we're dividing by L. So this is going to be L over theta squared. But it's probably a good idea to not express it as theta squared, because you might be tempted to put it into the integral, because but in this case, let's just call this theta prime because we know what that angle is. So that's theta prime squared in radians, of course. So now we have our outside constant simplified. Now we can just go ahead and compute this integral. So this is going to be a negative cosine, right? So this is now going to be a negative cosine of theta from 0.785 to 2.357, and then that all of that is being multiplied by this constant here. So this is going to be L over, so 90.08 in radians, that's about 1.572 squared, and you want to multiply that by the negative cosine of your upper limit, which is 2.357, minus the lower limit, so that's going to be plus cosine of the lower limit here, which is 0.785. So you go ahead and compute that. Now you find that once you compute this here, it's going to give you something like 0.572 L. So you can always just punch this whole thing into the calculator, where this upper limit goes here, this lower limit goes here, and you get something like this. But remember, that's the position of the center of mass with respect to the origin here, but we want to calculate it from the top. So now we want to find what the actual total height of that center is. So the total height of the center rod is just L over theta prime. So this is just L over 1.572. And if I do this, if I calculate this, I'll find that that's equal to 0.636 L. Right. So we now have R and we now have Y prime. So now we can go ahead and calculate the distance that the center of mass is below. So that's just going to be the difference between these two. So it's 0.636 minus 0.572 L. So this is the distance that they're looking for, Y prime of the center of mass. So if you do this subtraction, you will notice that this difference is just 0.064 L, which is your solution.